Morning. Oh, they can't see. We're continuing on yesterday's packet. On the top it said methods and meanings, and it has to do with multiplying using area or models of area. Okay, so that's still... All right, here we go. All right. Most of you, if I could have your attention up this way. Most of you had gotten to this page. Some of you finished this page. I wanted to take a look at it together, in part because these shaded things, it's hard to see what's going on inside. But what I see very, very faintly is that this size of that side is a X. This side of this side is a Y. And this little tiny one, that's a 1. So along the bottom of that rectangle, the longer one Y, and this one X, and this one 1. I'm going to go ahead and put that same thing along the top. And now I'm going to look at what's happening along the side. That's a 1, 1, 1, 1. What size is this?
X.
That's an X. Okay, and whatever I have on this side will be exactly what we put on that side. So this is 1, 1, 1, 1, and that's an X. So what we did yesterday is say, if you're looking at multiplying, a lot of times expressions can be represented as a shape. And that shape, when you're multiplying, you're actually finding the surface area. Base times height, like we've been working on. Well, the base and height look a little different here. First of all, if I take these shapes and I look along this side and I simplify this, this side is Y plus X plus, what's 1 plus 1?
2.
2. So if I wanted to look at a simplified version of that side, this is how I'd have to write it. I can't add an X and a Y, but I can add the two numbers right here. And then if I wanted to simplify what I'm seeing on this side, I have an X plus 1, 2, 3, 4. So again, we're trying to learn how to multiply, and we're thinking about it in terms of what we know about area. One way to represent the area of this rectangle is by product. Thank you. And I'm going to take those two, X plus 4, as an expression, and Y plus X plus 2 as an expression. So this is one version of a way that we could write the area of this rectangle. What was the other way we could write it? The sum. So we did two ways yesterday, product and sum. The product didn't really do the multiply. It wrote it as a multiply expression, but it was usually base times height or length times width, which is what we know about area. For the sum, we're looking at, instead of the whole rectangle, individual pieces, one at a time, finding their length times width. So in this individual piece right here, this big one, on one side I have an X, and on the other side I have a Y. X, Y, write that in dark. Then if I look at this square, all right, I can see one side is X, the other side is X as well. It's this length. So what's X times X? X squared. Now, let's look at one of these long, tall, skinny slivers. Okay, it has an X on one side, and it's only a little tiny 1 on the other side. What happens when you multiply 1 times X? That's an X. So right here is an X. This is also an X. Is there anywhere else on that rectangle where we see this same shape? Do we see little tiny rectangles that are 1 by X? Are those the only two? Right here. X, 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 X. And we could have got that by saying length times width. The length is X and the width is that little tiny 1. Okay, so now I have everything along this bottom row, the area figured out. And then I have some little tiny squares over here and some long skinny rectangles right there. Let's look at the long skinny rectangle. On one end of this rectangle it's 1, and on the long side it's indicated as length y. What happens when you go 1 times y? Okay, so right here its area, base times height, is y. Gosh, it's so tiny I can hardly y. So I have 4 rectangles that have area of y. Now I have 8 little squares. Let's look at this one in the corner. What's its length and width? 1. What happens when we multiply 1 times 1? So all of these inside have a 1. 1 by 1, 1 by 1, 1 by 1, 1 by 1. All right. So for sum is going to be sum of the areas. We had to look at each individual rectangle, multiply its length and width, and now we can simplify a little bit. The first thing that we're going to put over here is anything that's squared. You usually do these in descending order of exponent. So do we have anything squared in the middle? Y, X, Y. Oh, there's an X squared. So that's going to be the first thing we write. The second thing we'll write is we kind of have a choice. Do you guys want to write the XY? Why don't we write that XY? Because it's all by itself. There's only one of them. So I've taken care of, I've put into my sum already this one and that one. All right. Now we're going to start adding some things up to simplify. How many y's do we see? 4. So 4y plus, they're like terms, so at this step I can combine them, Andy. I need you not to be looking at your phone, to be looking up here, please. Okay, so I just took care of the y's. 1, 2, 3, 4 y's. For this sum, I'm adding up those areas that we found. I can do the same thing with x's. There's 1, 2, 3, 4, 5, 6 rectangles whose area is 1 by x or x. Okay, so 6x. 1, 2, 3, 4, 5, 6. So those are the ones I've taken care of in my simplified sum. One more piece. All these little squares. How many do I have? And what's their area? 1. So what's the last thing I'm going to write? 8. All right. So now this is one way to write the area of that rectangle, and this is another way to write the area of that rectangle. This is in product form, length times width, and it shows what you would do to multiply. This is in sum form. You've already multiplied the individual pieces, but then you kind of collected up like terms and added them together. All right? If you have not done that already, please do that for this rectangle shown down below. I'll be walking around. Start by going along the edges and figuring out what are the links shown there in the tiles. Excuse me? What are you going over there for? Why don't you hold on to them, because we're going to look at what to do at the end here. One, the little skinny, you were right, it's X from here to here, but what you're doing is from here to here is size 1. Okay, we're doing this. We're going to figure out what size everything. There are no numbers. You're going to put them along the edges and then write them in. Oh, good. That red pen is showing up nice. Okay, good. That's weird. This is so easy. Sorry. I think we only have X's here. You called it X right here, so that's going to be an X. But right here is not X squared. If you're looking from here to here, that's just X. It's only after you multiply and then it's X squared in the middle. Yeah. Right aside the edge. Because you're going to need to write it as a product. And so for the product, you're going to simplify how many X's you have. Alright. Here's what happens next. That's right. So far, so good. Now, 2 things. First, you can write what it is in the product. First product, you're just looking at the sides and you got to figure out what your length is. This one would be 1, 2, 3, 4 X plus how many ones? Going this way, I see 1, 2X plus how many ones? Okay, so that's the product. Now, for the sum, as a first step, you gotta go X squared. Okay. 1 times X is X. 1 times 1 is 1. Okay, so you have kind of 20 tiny rectangles there. Does that make sense? 20 kind of? All the sides are with this squared. Do you have a pen? Yeah. All of these sides are X squared. And then this one is 1 by X. 1 times X. Everything this side is X. And then this is 1 by 1. 1 times 1. Everything this side is 1. Go ahead, write them in, and then for the sum, you're going to collect them up. How many X squareds do I have? How many X's? How many ones? This right. Maybe they're close. So we just write that. That's in there. Now over here. For x squared. Yeah. Right here. All right, my friends. Okay. Take a look up this way. X, 1, 1, 1, 1, 1. If I'm just looking at this side, how many x's, how many 1's? 4x plus 5. If I'm looking at this side, x, 1, 1, 1. How many x's, how many 1's? 2x plus 3. There's the area expressed as length times width. After I identify individual pieces and simplify. Now, if I'm going to do it as a sum, I need to figure out the shapes. Now, this square is x times x. What happens when you multiply length times width in that little square? What's x times x?
X squared.
X squared as a size. I have 1, 2, 3, 4, 5, 6, 7, 8 pieces that size. 8x squared. I'm fast forwarding this a little now that you're kind of getting it. Now I have a different kind of rectangle, or maybe it'll be easier to look at right here. This kind of rectangle has 1 on the bottom and x on the side. When I go length times width, I get 1x. How many rectangles do I have that size? 1, 2, 3, 4, 5, 10 right here. And do I have that same rectangle? And then I have 3 more is 13, 3 more is 16, 3 more is 19, 3 more is 22. Once I figured out where my shapes were, did I have to write an X in every single one? No, it actually made it harder to look at, right? But I do have a system for figuring out counting them. Okay, that was one shape. This was one shape, and so far I've counted them. Now I have all these little boxes. What's their dimensions? What's their length and width? 1 by 1. What happens when you multiply 1 times 1? So the individual areas are 1. How many of those do I have? 3 by 5 is 15. Are you getting this? Some people yes, some people no.
Some people, yeah.
Okay, some people more or less. Now, looking at the rest of this worksheet, here's some more of those. Here's some where a lot of the work was already done for you. You just have to write the expressions, both as area of product and sum. Okay? And then they throw these down at the bottom of the page. Okay? Let's take a look at this. The first thing to know is you're going to need more paper to do 7 through 18. So I'm going to take 7 and transfer it to a new paper. All right. Do you need paper? Are you going to write this somewhere? We should do this together.
Paper?
7 through 18, you can't do on the page right here. They throw a whole bunch of problems at you, and you're going to need some space.
Is this the...
Over there is blank paper.
Actually, I don't need any other piece of paper.
Yeah.
You left your headphones on the bus. I haven't.
Oh,
That's a round
Okay, so they give it to you already in product form. In product form, this is the length, that's the width. We're going to keep using this area model. You'll draw a rectangle that's 2 by 2. Because that's what you're multiplying, an expression that's 2 pieces by 2 pieces. On one side, I'm going to put 3x and a 2. On the other side, I'm going to put 2x and a 7. So they are giving it to you already in product form. And I knew how many boxes to make by looking at how many terms were in each part. Yes, Andy? Okay. So I've got the 3x plus 2 I put here, the 2x plus 7. It doesn't matter which one was on top, which one's on bottom. You're going to simplify later. I go ahead and find the areas of individual boxes by going length times width in the smaller piece. 2x times 3x, I go 2 times 3, which is 6. And what's x times x?
6x squared.
Then for this box right here, I have 7 times 3x. 3x times 7. 21x. Right here, this is the intersection of 2 and 2x. What's 2 times 2x?
4x.
Right here, this is the intersection of 2 and 7. 14. So now we already had it in product form. Here's the sum. I'm going to put the x squared term first. Most of these will have some stuff you can combine some like terms. It depends. Sometimes they throw in different variables there that don't combine. But here I have a 4x and a 21x. They combine because they're both x terms. And then lastly, I have a 14 that has no variable. This was given to you in product form. Your final answer will be in sum form. One step in the middle that we're practicing, because it helps people make sense of this, is using this model of area. All right? Okay, so you're going to keep going on this page, including doing that 7 through 18 at the bottom. And then you're working on your homework packet when you're done. Yes. Okay, I'll come your direction. Here we go.